Hi guys, today we're going to be talking about series circuits and how energy flows through them. So what is a series circuit? So we talked about this a little bit yesterday. In a series circuit, current only follows one path, um, and this is the only way electricity can flow. Current follows only one path from positive to negative end of a battery. So now let's draw a circuit diagram of a closed series circuit with a 1.5 battery and 3 light bulbs. So here we see a series circuit drawn out, and you can see from the red arrows that current goes from positive to the negative end, and it's all a closed path and it's only one path. So this just describes a series circuit. So the next question to ask is what happens, for example, if I break that? Okay, so if I open it, all these lights would go out. Okay, and there would be no light. So why are Christmas lights wired in series circuit? So before we get into that, we review closed circuits, which in a closed circuit, electricity travels through the wire to the filament in the bulb. And so this is inside this portion right here, causing it to glow. So then it continues going on to the next bulb and so on and so on. If it burns out, like it might in your Christmas trees, then current can't flow. And so some lights are in series as shown in this bottom picture. So what if I were to break one of these, all the lights would go off. As opposed to parallel circuits, as seen in this picture below, if one of them is out, the other ones are still on. And so some of you guys did a good job yesterday and were able to make series and parallel. So because in a series circuit, there's only one path, current is the same at any point in the circuit. And remember, we identify current with an I, and current is in amps. So we can use Ohm's law to calculate the current, which we have been doing now, if you know the voltage and the resistance. And again, voltage is in volts, resistance is in ohms. So whenever we add resistors in a circuit, it's like adding pinches in a hose. So the greater number of pinches, for example here, the more resistance to current or flow. And so with each pinch, we're adding more resistance. And so we figure out that the total resistance is the sum of the resistances from each pinch. So in a series circuit, it's simple. We just add the resistances together, and that's how we get our total resistance. And then once again, here's the formula for it. So sometimes it'll tell you to calculate R total, which is the total resistance in ohms. So for example, let's say we have a closed series circuit and it contains a 12-volt battery and 3 bulbs with the resistances of 1 ohm, 2 ohms, and 3 ohms. What is the current in the circuit? So first we have to draw a circuit diagram. And so we start with the battery. So the battery will look something like this. And the battery is a 12 volt. Okay, and then we have 3 resistances, and we denote that with this symbol. So that's 1 resistance, and maybe I'll add another one here. I'm gonna add another one here just to make it all even, but it doesn't matter where I put them as long as there's 3. So one is 1 ohm, one is 2 ohms, and another is 3 ohms. Okay, so first I know my volts is 12. So V is 12. My R total, I just have to add my resistances together. So 1 ohm plus 2 ohms plus 3 ohms. So 3, 4, 5, 6 ohms. Okay, so now I have voltage, I have resistance. Now I can calculate current, which is V over R. My voltage was 12, my resistance was 6, so 12 divided by 6 gives me 2 amps. Now let's say we have a closed circuit of a string of 5 lights which run on a 9-volt battery. If each bulb has a resistance of 2 ohms, what is the current? So we start by drawing a diagram. And so we have the battery here, 9 volts. And then you might see light bulbs denoted like this, and it has a circle. So that's 1 bulb, that's 2 bulbs, 3 bulbs, 4, 5. And that's the string. And remember, we have to close it so we can have one path. And it says each bulb has a resistance of 2 ohms. So I would draw it out also on your paper, 2 ohms. Okay. So first I need to have my variable. So my voltage is 9 volts. My R total, my total resistance is just the adding of all my resistances, which I'm going to do all the way. So 2 plus 2 plus 2 plus 2 plus 2 equals 10 ohms. So in order to find current, I just do voltage over resistance, and we have 9 volts divided by 10 ohms, which is 9 over 10 or 0.9 amps. So now that we've gone over 2 problems, you might want to pause the video and do this one on your own to see if you really get it. And if not, then you can come up and ask me questions on how to solve this. So in a closed series circuit operates on a 6-volt battery and has 2 1-ohm resistors. What is the current? First, draw a diagram. Okay, so we've been drawing the batteries like this, and that's 6 volts. And we have 2 resistors, so let's say one here, and another one here. And I could draw these wherever, and then both 1 ohm. So I know my voltage is 6, my resistance, my R total is just the addition of all my resistances. 1 ohm plus 1 ohm equals 2 ohms. So current is equal to V over R. My voltage was 6 and my resistance is 2. So 6 divided by 2 is 3 amps. So with each separate bulb resistor in the circuit, this creates a voltage drop. The more you add, the less voltage you'll have. But current still stays the same. So voltage gets lower after each device that uses power. So in this circuit, we see that we have 3 bulbs that are identical, and they each give off the same amount of light and heat. Each uses the same amount of power. So a meter will show that the voltage drops from 3 to 2 to 1. Once it passes a bulb here, last bulb, it goes down to 0 volts. After passing to the last bulb, as you see it's going toward the left, the current returns to the battery where it is given more power and the cycle starts over. So here's 2 diagrams. On the left we have a more descriptive diagram like what we did in the lab yesterday. But here on the right is kind of what you would actually see on an exam or practice problems, which is the same thing. So we have 3 identical bulbs, and they're each connected in series with a 2 1.5 volt batteries. So because we have 2 1.5 volt batteries, we multiply that by 2 and we get 3 volts. Okay, so the total resistance here, remember, to get the total resistance is very easy for a series. R total, we just add them up. So we have 1 ohm plus 1 ohm plus 1 ohm. That's just equal to 3 ohms. So how much current is flowing through here? So to find current, remember we do I equals V over R. So my voltage is 3 volts, and my resistance that I just figured out is also 3, but it's ohms. So 3 divided by 3 is 1. So we currently have 1 amp going through here. So I'm going to write it here, 1 amp is flowing through the circuit. So each bulb creates a voltage drop of 1 volt. And how do we calculate that? So to calculate voltage drop, we use the equation V equals IR. So for example, take the current that we have here, 1 amp, and we multiply it by the resistance. So remember we said that each bulb has a resistance of 1. So 1 times 1. There. So each bulb is going to drop the voltage down by 1. And so we see that right here. Okay. The total of all the voltage drops is 3V. So if you notice, I dropped -1, -1, -1, that's 3V. which happens to be the same as your battery. And so all of this just cycles through. So the law of conservation of energy also applies to circuits. So the energy has to be the same. So the total of the voltage drops must add up to the battery's voltage. And we use Ohm's law. So Ohm's law, we can use this version or this. It's the same thing. It's just drawn out differently. So this formula must be used for each resistance in a circuit to calculate the voltage drop. So let's say, for example, this circuit contains a 9-volt battery, a 1 ohm bulb, and a 2 ohm bulb. Calculate the circuit's total resistance and current. Then find each bulb's voltage drop. Okay. So the total resistance is easy. We just add them up. R total equals 1 ohm plus 2 ohms equals 3 ohms. Now let's find the current. So current is I equals voltage over resistance. My voltage was 9V and my total resistance is 3 ohms. Okay, so 9 divided by 3, we have 3 amps. Now to find the bulb's voltage drop. So with the addition of each bulb, we're going to have a voltage drop. So to find the voltage drop, we must use this equation, V equals IR. So we take the current that we just figured out, 3 amps. And let's take, for example, this first bulb. And I'm going to label it. This is the first one, and this is the second one. And so the first bulb has a resistance of 1 ohm. So the voltage drop would be 3 volts. So I'm going to draw it with a different color. It would take minus 3. It would drop it by 3 volts. Now let's see how much the other bulb drops it by. So we take the current that we figured out, which was 3. And this number 2 light bulb has 2 ohms. So 3 times 2 is 6 volts. So it drops the voltage by 6. So minus 6 volts. So what do we notice? If we add these two up, 6 plus 3 equals 9V. So the voltage drop must equal the voltage in the battery. So another thing we have to do is we have to calculate the power of a device in a circuit. So we must multiply the voltage drop by the current. And so power is in watts, and then we still have current in amps and voltage in as V. So most electrical appliances like photocopiers or maybe microwaves, you'll see that it says watts or kilowatts. The kilowatt is used for large amounts of power. So 1 kilowatt equals 1,000 watts. So in your practice problems today, you will be asked to change one of your answers from watts to kilowatts. So let's say, for example, they gave you 5,000 watts. How many kilowatts? Well, you just got to divide that by 1,000. And you get, for example, 5 kilowatts. So let's take a practice problem with power. We have a 12-volt battery and it's connected in series to 2 identical light bulbs. The current in the circuit is 3 amps. Calculate the power output of the battery. So we know from the formula power equals current times voltage. Well, my current is 3 amps all across, so 3. My voltage is 12V on the battery. So 12 times 3 is just 36 watts. Now, for example, if you want to convert that to kilowatts, I would just take 36 and divide it by 1,000. And that gives me 0.036 kilowatts.